I'll add that you wouldn't want to do the derivative in this form. You would want to put this in more simplified form, and the simplified form would be, and so you have 2x times 1/2, which is x, then times x cubed minus 3x to the negative 1/2. You've got x squared minus 3 twice here, so that's x squared minus 3. I forgot to write the square, neglected to write the square. So you have x squared minus 3 squared, and times your x cubed minus 3x to the negative 3/2 times the 1/2 times negative 1/2, which is negative 1/4. So when you take this next derivative again, you have a product here, and you have a product here. And one of the functions in the product is a composite function. So it's going to get a little bit messy. Manageable, but messy. Now we take some higher derivatives, just the first and the second derivative, because the derivatives get pretty complicated. First and second derivative of y equals the cube root of x cubed, square root of x cubed minus 3x. Now we first write this as x cubed minus 3x to the 1/2, so we can easily express this as a composite. And I use the 1/2 because people are a little more comfortable with that at this stage than with a square root. So this is a composite function. It's the 1/2 power of 3x of x cubed minus 3x. So this is of the form f of g of x, with g of x, the first function that we evaluate. If we've given a value of x, the first thing we're going to do is find x cubed minus 3x. So the g of x function is x cubed minus 3x, and then what do we do with that? We take the 1/2 power. So our g of x function is x cubed minus 3x. Our f of u is u to the 1/2, so that when we do f of g of x, we replace u with g of x, so that we get f of u equals g of x to the 1/2, g of x being this expression. That's just this expression here, the x cubed minus 3x to the 1/2. Then we use the chain rule. Now, I'm not going to be real explicit about how the chain rule is used, but I'll note the parts of the chain rule. What do we have to do? We have to find g prime of x times f prime of g of x. So g prime of x is what? Well, g of x is x cubed minus 3x. The derivative of that is x squared minus 3. And then what's f prime of g of x? Well, f prime is what? F is u to the 1/2, so f prime is going to be 1/2 u to the negative 1/2. So that we're going to have 1/2, well, then f prime of g of x will be 1/2 times x cubed minus 3x to the negative 1/2. And you should understand that. That's fairly straightforward. Okay. Now, I didn't bring the 1/2 out in front here. I could well have done so, but I just kind of left it where it is. And we now take the second derivative. Now, the problem when we take the second derivative is, what is this function now? This is a product of this function and this function. So we're going to use the f prime g plus f g prime. The f prime, well, here's our f function. Here's our g function. So f prime is indicated here, times g, and then the f function times the g prime. So we see things are already getting a little more complicated. Okay, well, the expression over here is not bad. We're going to end up with 2x times 1/2 and the quantity x. Well, derivative of x squared minus 3 is just 2x. So we're going to have just 2x multiplied by this expression. Okay, over here, though, we have to apply the chain rule in order to take the derivative of x cubed minus 3x to the negative 1/2. Now, here I do bring the 1/2 out, at least out of here. I could have brought it out to the front. That probably would have been better form. But I'll express my x cubed minus 3 times 1/2 here. And then my derivative of, well, my g prime of x times f prime of g of x here. Now, our composite is f of u is going to be u to the negative 1/2, and our g of x is going to be x cubed minus 3x. So our g prime is going to be x squared minus 3. And that's going to, of course, match the g prime we had previously. So a pattern begins to emerge there. And then our f prime of u, f of u is going to be u to the negative 1/2. So f prime is going to be negative 1/2 u to the negative 3/2. So there's our negative 1/2 times u to the negative 3/2. Of course, u being now g of x. So I haven't written this out in great detail, but we see that we get two terms, and each term now being a product function. When we take a third derivative, if we want to take a third derivative, if we need to take a third derivative, we probably don't really want to, but if we need to take a third derivative, we're going to have the derivative of this times this plus this times the derivative of this. And then over here we're going to have all this is one function times this plus this, can I say that right? The derivative of all this times this plus this times the derivative of this. And you can see where this is going. Now we're not going to go any further. At this point, you need a little more experience in taking derivatives before you would find it profitable to go on to another derivative of this function.